a little bit bridge-like. And then the binding are the ones that are like, so like polypores have all three, they're trimitic. So it just makes sense. Like you'd want your mycelial mat to have like trimitic species, right? And maybe the ones that are actually gonna like eat the O. coli are like the just have generative, but like you have the other ones like holding it together.
This is.
Yeah, I'm having a hard time seeing on it. Geez, what did it say? Yeah, so just living questions. Obviously, it takes a team. I was talking about these different species, successional filtration. The whole idea of like biomimicry, going out there and studying what nature's already doing. Been trying to hang out a lot in riverbeds and just asking and listening. This whole idea again of like we're still kind of curious about this whole like enzyme time factor.
Yeah,
I actually have
how much of the mycelium is just grabbing that E. coli and eating it, and how much of it is enzymes that it excretes and that kill those too.
And like what's the contact time? Because depending on the slope of your filtration system, if it doesn't have enough contact time, well, the E. coli is just going to move down to the next pit of water. And then the other question I have, which I'm like kind of concerned about, is just what's the potential we could be creating habitat for E. coli in like little aquatic terrestrial subparts on the way down. So that's like a serious thing to figure out.
And also, is that a problem? You think that's a problem?
Again,
it might be a problem.
yeah.
Or it might be an okay thing.
We just don't want to do harm, you know, like we're, like we're humans. We tend to mess things up, but we're also learning to heal, and hopefully we can be a healing agent in this. Because the whole point is we're trying to heal another mistake we made of like mismanaged, yes.
So you probably are all familiar with these resources. Do check out mycoevolve.net and Alex's website, mushroom-revival.com. It's got a dash, right? Yeah.
And Hannah's going to have a blog, something Hannah Hyphy.
Hannah's Hyphy.
I'm just
shy.
Why is that up there, Hannah?
Yeah.
Come on.
Put yourself out there.
Yeah.
Yeah. Hannah Hyphy?
Hannah
I'll
Hyphy,
probably
keep your eyes on it.
Okay.
And some of the specific studies on this stuff.
If you want, like, the grant we wrote in terms of, like, all the studies, for the course this week, we, like, had a Google Drive and shared, so we're happy to, like, send it to you. You can contact me, and I'm happy to, like, send it to you just because it's a lot of articles. It's worth... And,
This is just for this PowerPoint.
Yeah.
You want her to send the PowerPoint.
contact.
So, yeah, can you leave that up for this?
Yeah, and we have
We'll
cards.
make some thank yous and then go back to that
Perfect.
slide.
Yeah, so I just want to give a shout out to UVM Horticulture Farms, like, because of those connections to UVM, they hooked us up with like free wood chips that are actually hard to find in Vermont. So we have a biomass power plant that takes all the wood chips and burns them to like heat buildings. Thanks to UVM Greenhouse staff for being gracious with us. Vermont Myconode for like helping rescue us. My partner did a lot of volunteer time. Valhalla, Vermont, it's an awesome intentional community that's growing lavender and Myconodes living there, and Trad Cotter helped us out a lot.
And her name didn't make it on this version of the PowerPoint, but Jill Felker at Antioch, New England, for helping us out with the phosphate buffer, E. coli buffers issue. Okay.
So Alex is going to talk to us about water filtration.
Yeah, I'm going to talk about a few other stuff, but
Yeah.
if
You wanna
anyone
plug
wants
in?
to ask questions while I'm
do we
like
have any-
setting up.
Okay, do we have any questions before I say?
Round two, are you gonna like beyond writing other mushrooms, this is you can also
I think she's ready to move things down.
Sorry, this is the contact, so I apologize.
Oh yeah, yeah.
Good, good.
Are you good?
Yeah, I think what we're going to do after round one, when we get our data and analyze it, is then we're going to kind of look at how we could have done round one better and maybe modify and do some sub-trials, and maybe ramial wood chips would be better. I definitely think we're not just going to use one species.
Yeah.
So I think I'm immediately actually going to start propagating Ganoderma and Chlamydes and Lentimulas, actually start experimenting with that now. So I think phase two will probably be really different. But just take the baseline data we get about dilutions and mycelial mats and at least have that inform the next step.
and another question is like coming from an art t-shirt, you pointed with nice work and stuff. Do you have any suggestions for resources for, I mean, it's like a permaculture question, it's looking at how nature
That's a great question. I mean, that's my current next thing. Is like I've been hanging out in riverbeds a lot, or just natural and like observing who's growing where and how are they doing it, and then trying to like try it, you know, on our own. Right. As humans. Any last questions? Thank you.
Thanks, guys.
So I hope you enjoyed that and realize how complex life is and how juicy and exciting it is and how much more we need to learn and the exciting potential of microremediation and of life itself. I'm going to tell a little story of mushrooms and kind of how they work and hopefully it gains a better understanding of microremediation and through their eyes and how they can everyone hear me in the back? Cool. And how they work in our environment. Sure. What is this for this? Oh. Great. So there's this theory that mushrooms came from space, and mushrooms are aliens. As probably everyone knows, and if you don't know, we share over 50% of our DNA with fungi. So if that theory stands true, we're aliens. And that's it. That's all I have to say. Yeah, so there's this theory, and a lot of people try to debate it. And there's a kind of story going around that viable spores were found on a spaceship re-entering the atmosphere. Some people say that was just made up, but there is a story of people throwing out a piece of lichen out of the US space station for 6 months in the vacuum of space. They took it back on board and it continued to grow like nothing happened. So fungi are pretty resilient. So this is the actual image of that asteroid hitting Earth. Jessica, you took it, right? And this actually was found about a year ago. So some researchers were on a boat in the middle of the ocean taking rock samples from the Earth core and taking some of the rock pieces and putting them on Petri plates. And they found that one of the Petri plates actually started growing mycelium. And through carbon dating, they figured out, well, this is 20 million years old. These spores in this rock underneath the ocean. It actually started fruiting off the Petri dish. This is in the Schizophyllum family. So we can see this is spores, 20 million years in hibernation. So the theory of the asteroid floating through space, it's not that far out if it can survive underneath an ocean for 20 million years. So when the asteroid hit, fungi formed a symbiotic relationship with cyanobacteria. And now we're finding more about lichen and figuring out this is a relationship between like 10 different organisms. And sometimes more, sometimes less. But the theory goes that these were giant kind of termite mound shaped structures called prototaxites. And originally when humans found them, they did cross cuttings and they saw almost like rings of a tree. And they thought that they were trees, but DNA analysis found out that this was like 95% fungi. Like, wow, these are giant mushrooms, basically. But it's a symbiont. It's like a piece of lichen. And then there's this theory that these prototaxites evolved into trees, and early trees that we see today. And if you look at some ferns, they're still reproducing through spores. And you know, these trees you can see has the same base structure as the prototaxites. And it just makes sense. And if you look around, all these plants have mycorrhizal connections, have endophytic fungi. So it's basically the same lichen structure in a different form. So the theory goes that once they started making these prehistoric trees, the fungi, before they were the protective barrier for the photosynthetic organisms, and now they were like, I'm going underground. You can protect me. And they started going into the cell walls and doing a flip-flop, and creating a network in between these new trees being made. And this is where we get saprophytes. There's a period in the Carboniferous period where most fungi didn't have the enzymes capable of degrading lignin, hemicellulose, cellulose. So all these trees started building up and creating oil. It's like how most of us got here. So this is the basis of microremediation for chemicals. It's this period where fungi are interacting with the environment, are helping make these trees and these structures, and sending out their hyphal tips and saying, wow, these are building up and we got to do something about it. And it's just like our environment now. We're creating all these new structures, new chemicals, and fungi are in the environment interacting with our landfills, and creating new enzymatic pathways to deal with it. And so we start seeing a whole new group of fungi, saprophytic fungi, able to degrade this waste. And then there's another theory that fungi started to branch out. They said, okay, we're creating this symbiotic relationship. Can we branch out and create our own structures that are different from the lichenized structures? And our early ancestors stumbled upon some of them that had hallucinogenic properties. And some of them being Amanita muscaria, or an early ancestor of cubensis, off animal dung when we were hunters and gatherers. And of course, when we didn't have language yet, and we had that experience, there's a theory through epigenetics that we developed our evolution through time. This is a painting by Alex Gray. It's like a funny representation of Adam and Eve and the forbidden fruit. And this theory is laid out in Food of the Gods. It's a fun theory and a fun story to read. But we can see this evidence of this sacred relationship with humans and fungi. So first, in the start of time, fungi is starting this sacred relationship with cyanobacteria and these photosynthetic organisms, and now we're seeing kind of a divergence from those into humanoids. And they're really good with symbiosis, and we can see it here at this festival. They're bringing us all together. And religions were founded with mushrooms as the sole kind of praise, and we're a main part of so many religions and festivals and of the likes. But over time, not everywhere, but in a lot of different cultures and a lot of different places around the world, we've lost that connection, not only with fungi, not only with mushrooms, but nature, with plants, with the earth, and we started being disconnected from our environment and who we really are. So we started polluting and making these recalcitrant compounds and putting them into the environment, and that's where fungi comes in. We started this sacred relationship. We can see when they developed the enzymatic pathways to break down these trees and break down these other man-made anthropogenic xenotoxins in our environment. We can see this revival of what we're working to come back to, and this is kind of the basis of this company that I founded, of working with medicinal mushrooms, and also microremediation is healing within and without. I published this book last year about microremediation and mushroom cultivation on the same path of, we lost our connection. Not everyone, not all cultures, not all peoples, but a lot of people, and it's kind of this remembrance of like, hey, we got to do something about it. and form this allyship even more. And this is a project that I did last year on cigarette butts. So I got inspired and started growing mycelium on cigarette butts, and working with petri dishes at first, but then in jars and 5-gallon buckets, and trying to work this into a more commercial scale. And I came down almost by mistake and opened the lid of this bucket that I just forgot about and pulled these cigarettes butts out, and started getting curious of like, well, are the mushrooms hyperaccumulating heavy metals? Can you eat the mushrooms? And of course, yes, they are toxic. And then I did some studies on, well, are they breaking down the chemicals? So yes, the heavy metals, they're pulling them up. Are they breaking down the polycyclic aromatic hydrocarbons, which are very mutagenic, they cause cancer, pretty bad for us to consume. And so this is a picture of the cake of cigarette butts and oyster mushrooms fruiting off of it after pulling it out of a 5-gallon bucket. And found this was the experiment in jars. But I did some experiments with, is mycelium better? Is the enzymes from mycelium better? Is enzymes and mycelium? Is compost tea? And how do all these things relate to a commercial remediative standpoint? Because if you look at microremediation, you read Mycelium Running, he just talks about throwing spawn on an oil pile. And like, it's like that, it can't be that easy. And like, what are some other alternatives to this? And I got thinking, and I was like, well, for chemicals, what is the main catalyst for degradation? Enzymes. And I was working at a gourmet mushroom farm at the time, and started seeing all these enzymes pool at the bottom of the bags. Because the mister systems would wash down the side of the blocks and pool all these enzymes at the bottom of these blocks. I'm like, you can drink that for novel antibiotics, you can like do all types of stuff for all these different industries, and for microremediation. And these were the results for the polycyclic aromatic hydrocarbons. This is the detectable limits, and this is where it started, parts per million of polycyclic aromatic hydrocarbons. And I tested every 2 weeks, and I should have done like every hour, but it almost totally remediated the PAHs within 2 weeks. And it got similar results with compost tea. So I got really thinking, there are commercial enzyme producers. You look at Novozymes. They're huge. They're in like 180 countries. They're like, go on their website. They're amazing. And it's multi-billion-dollar industries that they're working into. Like, what can we do with it? It's a liquid. How can you apply a liquid on a mass scale? And I started just doing research of like, what can we use this for brownfield sites, Superfund sites, oil spills in the ocean, things like that. And I came across this. There's a lot of forest fires, and there's these fire trucks that go out, and they actually carry a tank of liquid, and you can spray it on a brownfield site or a landfill, or an urban lot or something, and keep and mobilize enzymes and compost tea in this bin. Now, in my last experiment with the cigarette butts, they were untrained. So a lot of people say you got to train the mushrooms to like slowly get used to this toxin. Those results of almost completely remediating the PAHs was just, I was used to eating sawdust. So this is really profound of like, yes, we can use the enzymes, the waste product of big commercial mushroom farms, and we don't have to train it, we don't have to do any special things, and we can put all their spent blocks in just like a vessel, wash water down, collect all the enzymes, and spray it. And this can be used in traditional, remediative techniques. This is called windrow composting, and it's being used by Bob Rawson, who's part of Co-Renewal, working to remediate oil contaminated soil in Soconvíos in Ecuador. And so what happens is they have these long piles of contaminated soil, and they flip it, and as they're flipping the soil, they're spraying it with this iOS 500 bacterial mix. And bacteria can only break down low weight, smaller chain hydrocarbons, and less complex chemicals and molecules. But fungal enzymes can break down the harder, more calcitrant compounds that are heavier weight. So a combination of both the bacterial tea and the enzymes as a shelf-stable liquid. And you can even spray dry it, you can freeze dry it into a powder and throw it on a shelf at room temperature for a while, like years, ship it across the world. And it's not heavy like a liquid, it's really lightweight like a powder. And if you have contaminants really deep in the soil, this is a technique called bioventing. And a lot of remediators will pump air and nutrients really deep into the soil. As you can see, this is an air vent, this is nutrient feed, and this is like, an oil pit really deep in the soil. And the same thing can be done with the enzymes and the bacterial tea. But this is being done on an industrial scale, and we don't hear about it because it's locked in research, it's locked in patents, it's locked in a lot of money, to be honest. The remediation business is, pretty profitable. So this is one kind of like really basic example of a fungal bioreactor for dye water. And this is used for industries that have toxic dye as their byproduct. And it's like pretty simple. They have discs of mycelium rotating in the dye water, releasing their enzymes, and they're rotating so they don't suffocate and the mycelium dies. And basically, remediating the dye before they release it into the river. So this is an example of industrial microremediation, industrial water cleanup. And we can do this for a lot more things. What about an oil spill in the ocean? We were just talking about salt tolerance for fungi, and not a lot of fungi have much of a salt tolerance, so they wouldn't be able to be floating in the ocean in like a mycelial raft. So one industrial technique that we use is incineration. We just burn it. If anyone has seen any of this on the news at any point in their life, it's pretty scary. This is huge. I don't know if you can see this like part of a boat. Sometimes they're even bigger. Job well done, right? It's all good. Another method is dispersants, and there's a lot of other methods for industrial ocean oil spill cleanup. But dispersants, basically, if anyone has washed an oily pan with soap in your sink, the oil balls up and drops down your sink really easily. Same thing happens with dispersants, and it just drops to the bottom of the ocean. Job well done, right? And sometimes, like the BP oil spill, the dispersant interacts with the compounds and makes even more toxic volatile compounds. So we saw in Earth Repair by Layla Darwish, she talks about a lot of the remediators were pouring this dispersant on, and were inhaling the fumes and actually getting very sick, and a lot of them died because it actually made it a lot more toxic. As you were talking about of like, well, it's good to have good intentions, but we need to know if this is actually going to make it worse. So why not, instead of dispersants, use this enzymatic bacterial tea spray? to break down the oil on the surface. And this doesn't have to be salt tolerant because it's not interacting with the mycelium, it's just the byproduct of the mycelium. And if we want, we can train it in the lab. So we can train, mycelium on a mass scale to interact with these hydrocarbons, release these enzymes, and then take it up into an airplane and shoot it over. And this could also be done on a Superfund site, brownfield site, a contaminated river, whatever you're dealing with, or an island of trash. We have islands of plastic and trash the size of Texas in our oceans, and we have a few, and we're continually finding fungi that can break down novel plastics like polyurethane, and this is continually being found, and biochem researchers are genetically engineering fungi to better break down plastics, and some people are like terrified of that notion. And I think if it's done in a controlled setting, it may be beneficial. But, in this case, it might be better to sift up the plastics and do it in a controlled setting to avoid nanoplastics. If you start breaking down these islands of plastic in the ocean, you might make it worse by creating a lot of nanoplastics. Fish eat them, we eat the fish, we're eating that. So sifting it up first and then doing it in a controlled setting. But the possibilities are endless. And I want everyone to leave here like thinking with an open mind of how can we implement these systems on a big scale. Because we're coming to a point where we have no choice. And that's pretty scary, is like, we can put our trash on the curb every week and just like go like that, or we can really face it, and the landfills are starting to pile up, the toxicity is starting to pile up, more pipelines are bursting, and it is starting on indigenous land, it's starting on land that is predominantly people of color, and so for a lot of us at this festival who have the privilege of having lighter skin, we're not affected by these toxicities as much, but there's coming a point where we can't hide from it anymore. So that leaves us with, how do we take this home? How do we take this whole festival home? We need to keep connecting with people. We need to keep hosting these events. We need to, use the mycelial internet and connect to people, all over the world, and trade open source information, and say, I found this works over here, I did this in my climate, I have this culture, and keep learning and teaching and sharing that information like fungi, in a symbiotic relationship, like mycorrhizae, and we need to prepare, because it's already happening, we're in it. There's no turning back. It's not like, oh, what if it happens in a year or something? Like, we're in it. It's happening. And we need to take action. So no more sitting around. We need to, do it. No more reading a book. No more, just talking about it. We need to experiment. We need to, fuck up. We need to make mistakes and just keep replicating it and keep trying. And trying our best. So with that, I want everyone to leave and infect the others and start this mycelial army and clean up our mess. So thank you, and thank everyone here. Thanks for being here and showing up. Really appreciate it. So I'll take any questions if anyone has any.
I guess, where do you get started? Do you get started in, a university? I have ideas for experiments, but I don't have the money to do them, so, where do you get started?
Yeah, I mean, you're sitting next to someone who's really amazing at finance, and grants. So if you're worried about financing your projects, talk to her. If you're open to it, I don't want to, put you on the spot, but, it's all what your end goal is. If you're I want to take on big oil spills, or big industrial contamination, a lot of times you need to go through, you know, a PhD program, and these programs to get the skills and the credentials to really tackle it. If you're like, yeah, I just want to do grassroots, like, you know, lots in my city, a lot of times you don't need credentials, and a lot of times it's like just reading books, connecting with people, composting, planting. It doesn't even have to be mushrooms. Like, I would love to put a mushroom on a pedestal at all times, but you know, it's all systems interacting all the time. Even just like having a compost pile is awesome. You know, you're creating soil. You're creating this new earth that we want to take. So ask yourself, where am I going? What's the like end goal? And connect to everyone else and ask that question to as many people at this weekend as possible, and get as much answers and form a network. Sure.
Yeah, just one other thing is like if you think about inventory of where you live in your community and make a list of like all the problems, and then like pick a couple solutions that you see are viable, that you're passionate about, and then like what skill set do you need to cultivate it, and then maybe if it does involve fungi, you can just do like really simple cultivation, like just learning.
Where do you live?
Bucks County, Pennsylvania.
Anyone else?
Yeah, do you mind if I speak on that? I would say to like start with what you're passionate about. You know, if you are called by a cause and then you have a certain skill set, you know, you don't necessarily need to learn absolutely everything to do it, but potentially attracts the people that have those skill sets to do it. But by focusing on, you know, your alternative motive, you can inspire others to do similar work and get on board with it. And reach out to the resources that already exist. You know, you don't have to reinvent the wheel either. You know, there's networks that are in place that you can tap into, like your local mushroom clubs and things like that are already like a network that are meeting regularly, that you can then, you know, introduce new topics, and they might have funding for you and, you know, get behind you to inspire others.
And on another note, you know, you ask, where do I start? You've already started.
Yeah.
You're already here.
Yes.
You know, keep asking the questions.
Yes, you did.
Like, you're moving.
Yeah.
You're on the road. I get that question a lot of like, oh, I don't know what to do. I'm like, you're already doing it. You're here. You're in your body. You're like, do it. You know. So yeah.
Do you think mycophobia is a problem? If it's a mold like penicillin, fine. Once it looks like a mushroom, people are afraid. Do you encounter that?
Oh, of course. Especially in the United States, not all countries have mycophobia, and more. You know, there are other countries that have way more than the United States, and I know some people are way more afraid of molds than they are of, you know, Basidiomycota. So I think it depends. I think it is a problem, but I also think, you know, we need a pinch of it, because they are very powerful and they have the powers to kill people, and cause like serious damage, and we need to be, you know, have respect for them in that manner. We can't be like, oh, I love mushrooms, eat them all, like, you know, rub them all over my body, like all that. It's like, yeah, like some are pretty dangerous, so we need a, you know, bit of hesitancy, but they also have, you know, infinite things to give our society and our world. So I think more love for this whole kingdom, which we're learning more is like, you know, we share over 50% of our DNA with them. You know, we're basically them, and at one level, everything is one. So, yeah, more love for everything.
And I think in terms of that, like, we can make the change of how people view mushrooms. And I work in a cafe where I infuse them into chocolate chip cookies. So people come in and they're like, oh, mushrooms scare me. And I'm like, really? Do you like chocolate chip cookies? You know, just breaking that barrier of like there are these crazy things that they can really help us, and bringing them to through art and through delicious foods, and just spreading that change.
Sugar coated.
Yeah.
Dip
it in chocolate.
That's good.
What's like the largest scale industrial, ongoing mycoremediation industry out there? Are there any projects that are established in the industrial sector? Are they using big, I'm thinking about different types of industrial tools that are used for septic field cleanup, that sort of thing, aeration, enzymes, and just so I guess there's two questions there. One, what is the largest ongoing industrial scale microremediation going? And have you heard of these? Like you're saying, the spraying machines. There's aerating machines.
Totally.
Curious about all
Yeah,
that.
so there's a couple different answers. I'd say the largest grassroots would be co-renewal in Ecuador. But on an industrial scale, I haven't seen much with land remediation. But I've seen a lot with water. And I was talking about these like bioreactors. And a lot are focused on enzymes. And a lot with dye water or whey, or these waste products from these big industries being put through a fungal bioreactor to clean the water. That's huge, and a lot of them are not accessible, and you can't find much information because it's all proprietary. And then another side note is phytoremediation is huge, and with that a lot of people inoculate it with mycorrhizae, and that is a whole nother industry. But pure like mycoremediation would be mostly water on the bioreactor scale. Anyone else? Cool. Well, thanks everyone for showing up, and much love. May the sports be with you. Enjoy the rest of this conference. If you want some medicinal mushroom products, if you want to check out my book, it's The White Tent, 2 tents down.
Check out that other tab. So that's what
How you doing?
Good, how are you?
Oh, good. Yeah, you too. How's life?
It's been swell
Yeah.
this weekend, so
Yeah, I'm
housing's pretty close here too.
Yeah.
I would shoot more towards
Oh, really?
Yeah,
And it's north, right?
because he is a hydrologist, and
it's right near the Hudson, so
Oh, it
there's
is.
a lot more information on
Yeah.
hydrology.
yeah.
I'm gonna drop in one of these days. I
Yeah,
just
I have your
bought a house in
pamphlets
Kingston.
out on the table.
Thank you.
Yeah.
That's awesome. Love it. Yeah, I would love to do something together.
Yeah, that would be
So
awesome.
Yeah.
I'm really not
Yeah,
sure
maybe
how
next time Alex
or,
drops
like,
in and he was telling me about his experience there and
Yeah.
workshop and everything else. Sounds like
Yeah,
such
that
a
was
fun.
In what aspect?
I love it.
like
Yeah, just do a whole weekend long extravaganza.
Yeah.
for the weekend.
Yeah, that was great.
Yeah, I'd like to drop in on that.
One thing
How
I
fun.
would like,
What are you guys working on?
So we're working
and I
on
said this
building
before at a different
Pantheon,
yeah,
which is
just
like
like
this
I
big
guess
museum, temple, installation.
instead of
So it's
starting to
over 100
compete
of
against like
Alex's
each
artworks.
other
So
rather than
right now we don't even have like the sacred dinners, like the two sacred dinners.
Really?
We just have
And it would be cool to like have
handle
like
all
every
the sacred
single
dinners because it's all
thing
this
to be
stored
like, well,
house.
this
So
stream
we
is
have a
this,
lot of land,
blah,
but we
blah,
have
blah.
this open
Yeah, but
space
something
for
that like
artwork.
Tribe has
So
right
it's going to be this like interactive museum, like a VR room. It's going to have every piece of Alex's done a portrait of himself since he was like 4 years old. So it's like all, we're going to have all
Now I
of those on
think
this
it's
wall. I've never been
like he showed it to me
throughout his entire life.
and asked me about it. Like,